Hello class. Today we'll be at section 2.3, which is solving right triangles. Alright, so they start us off with giving us the definition of significant digits. So significant digits is a number, it's found by counting all the digits from left to right, starting with the first non-zero digit on the left. Alright, so, and then when no decimal point is present, trailing zeros are not considered significant. So for this first one, you would start counting at the 4 and the 2, which is 2. So that's why there are 2 significant digits. For the next one, you start counting at the 5. There's only 1. For the next one, you count starting at the 2 because that's the first non-zero. So 1, 2, 3. That's why there's 3 there. And for the next one, because of the decimal, you're going to count the 6, and then you're going to include all these zeros because of the decimal point. So that's going to be a total of 4. And then for the next one, because of the presence of that decimal, you're going to count 9, 2, 0, 0. That's 4 again. And then for the last one, since there's no decimal present, you're only going to count the 7, which is 1. All right, so that's how you determine the number of significant digits. For this one, they want you to know the accuracy of the angles in the same triangles shown in this table. So for accuracy of sides, you want 2 significant digits, and for angles, you want to round to the nearest degree. In the case where there's 3 significant digits for the side, you want the nearest 10 minutes or the 10th of a degree. And in the case of 4 significant digits, you want the angle to be to the nearest minute, which would translate to the 100th of a degree. All right, so let's take a look at this example. We have a right triangle. They give you A and B. We need to find the remaining side, which is a hypotenuse, and the 2 missing angles. So let's start by finding the hypotenuse. That's going to be the Pythagorean theorem. So A squared plus B squared equals C squared. So that means we have C squared is going to equal 3.41 squared plus 2.73 squared, which is 19.081. Taking the square root of both sides gives us 4.37 if you round to 2 decimal places. All right, so now we have that, 4.37. Now we can figure out the missing angles. Let's start with angle A. I'm going to use inverse tangent to use opposite adjacent. So start with the equation. Tangent of theta, or of angle A, is equal to opposite, which is 2.73, over adjacent, 3.41. That's opposite adjacent. To solve for A, you have to take the inverse, so the angle is equal to the inverse tangent of 2.73 over 3.41. So make sure you're in degree mode for this. And I get inverse tan 2.73 divided by 3.41. I'm getting 38.7 degrees. If I round to the nearest tenth. So that would be this. And then to find the missing angle up here, angle B, you would just find the complement of 38.7. So you can subtract 38.7 from 90. And that would be 90 minus 38.7, which is 51.3 degrees. That's how you would find the missing angles. For the next example, we have a Ferris wheel that was first designed in 1893. The diameter is 250. So from one point all the way to the opposite side would be 250, which means the radius has to be half of that, 125. So radius is 125 feet. All right, anything else of significance? Well, we know that it says here the top of the wheel was 264 from the above the ground. So from here all the way down to here is 264, but from here to here is 250. So that means that the distance between this point P sub 0 to the ground would have to be 14 feet because of this information that they tell us. All right, and they're asking us to find the height, h, when the position moves from P sub 0 to P sub 1, given that this angle is 45 degrees. So they give us a better picture over here. So there's a 14 that we talked about, because from the point to the top to the bottom is 264, and the distance from here to here is 250. So if you subtract, that gives you 14 for that piece. We know that the radius is 125, so that's the hypotenuse. This is the angle 45 that they told us. So what we need to do here is find h. In order to find h, we first need to find x. And then once we find x, well, we'll be able to find this little segment by subtracting 125, which is the radius, minus x. Will leave us with this little piece segment that we need. So let's find x by using cosine, adjacent over hypotenuse. So the cosine of 45 degrees is equal to adjacent over hypotenuse. And then if we multiply both sides of the equation by 125, that'll give us x isolated. So on the calculator, 125 times the cosine of 45 degrees is equal to 88.4 feet. So that would be the distance from here, from the center to here is 88.4, but we know the radius is 125. So in order to get this piece here, we just do 125 minus 88.4. So it's going to be 125 minus 88.4, which is 36.6. So the distance between this point and this point is 36.6 feet. And since this piece is 14 and this is a rectangle that has opposite sides congruent, that means that the distance from here to here is equal to the distance from here to here. So now all we got to do is add 36.6 to 14, and that'll be h. So h is going to equal to 36.6 plus 14, which is 50.6 feet. And that does it for this problem. That does it for this section. Let's go on to the homework now. So 2.3 homework, I will leave you these definition problems to you guys. Let's figure out the number of significant digits here. So we start counting from the left. So that's 1, 2, 3, 4 significant digits. For here, because there's a decimal point, we need to include these two zeros in our count. So 1, 2, 3, 4, 5, 6 significant digits. For the next one, we start with the first non-zero digit, which is 1, and start counting to the right. So 1, 2, 3, 4. The next one is 1, 2, 3, 4. Because of the decimal, we count those. Well, we count the non-zeros anyways. So that's 4. All right, for this next problem, they ask us to find the missing sides, or find A actually. So they give you angle B and side B. So let's draw this triangle on another sheet of paper. So I'm going to label this A, B, C, and we have angle B is 52.22 degrees, and we are also given side B is 15.38, so I'm missing the 2 here. 52.22, and we said side B, which would be opposite angle B. This is side B here. Side B is given to us as 15.38. So we need to find A. All right, so in order to find A, we would have to use tangent, because we know opposite and we want to know adjacent. So opposite over adjacent. So let's start off by using the tangent of 52.22 degrees is equal to opposite over adjacent. And there's our equation that we're going to use to solve for A. In order to get A isolated, we're going to have to get it out of the denominator, and we can do that by multiplying both sides of the equation by A. Now we have a tangent 52.22 degrees equals 15.38. And finally, we would divide both sides by tangent 52.22 degrees. And that gets you a isolated. So if you do the division on your calculators, you should get 15.38 divided by tangent of 52.22. And I am getting 11.92. 11.92. So that would do it. 11.92. Actually, they're asking us to round to 3 decimal places, so I need to go further. 11.921. All right. That's how you would find the missing sides and angles of a right triangle, given some information. Let's try another one. This time they are going to give us side A and side B. So let's draw that triangle. You can draw any generic right triangle, as long as you label it A, B, C, and you label all the given information. So A is 42.9. 42.9 would be opposite of angle A. Side B, 34.4 is opposite angle B. So 34.4 would be here. And we need to find the missing side and the missing angle. So I would start by finding the missing side, which is the hypotenuse. Label that C. So C squared is going to be equal to A squared plus B squared. So that would be 34.4 squared plus 42.9 squared is equal to 23.77. Taking the square root of both sides gives us 54.98, which I will round to 55.0 if you round up. So this would be 55.0. All right, and now we can find the missing angles. So let's start off by finding angle A, and I'm going to use tangent again, inverse tangent. First, I'm going to set up my equation as tangent A is equal to opposite over adjacent, which is 42.9 divided by 34.4. Taking the inverse tangent of both sides gives us 42.9 over 34.4. Let's see what we get here. Inverse tan, 42.9 divided by 34.4 is getting 51.3. 51.3 degrees. So that is your angle. And let's see how many decimals they want us to round here. It says find angle B, round to just 1 decimal place. So angle B, I found the wrong one. I was supposed to find the other one, but that's okay. We can just find the complement now. So 90 minus 51.3 is 38.7. So that would be our final answer, 38.7. So I just found the complement of 51.3, and it turned out to be 38.7. 38.7 degrees. All right, let's move on to the next problem. All right, this is pretty similar to what we've been doing, so I'm just going to go ahead and let you guys do that one. Let's try the last one. So it's the same thing, but we can do this one together. There's our right triangle. We have A, B, C. They give you A, which is 37, and they give you B, which is 89. And once again, let's look for the hypotenuse by using the Pythagorean theorem. I'll call that C. C squared would be 89 squared plus 37 squared, which is 9290. Taking the square root gives us 96.4. And they want us to round our answers to the nearest whole number, actually. So we need to round to the nearest whole number. So this would actually just be 96. Once we have that, now we can go ahead and use any trig function that we want. I think I will just stick with tangent and do opposite over adjacent for angle A. So tangent of A is opposite over adjacent. To solve for A, we take the inverse, tan, of 37 over 89. And that will give us 22.5, which means we round up to 23. So that would be 23 degrees for angle A. And to find angle B, now that you know what angle A is, you can simply just find the complement of 23, which means 90 minus 23, which is 67. And that concludes this section. Feel free to email me with any questions.